Today we're going to talk about direct variation, and while the term direct variation is a new term for you, the concept itself is something that we have been talking about and we're familiar with. Direct variation is actually the same thing as proportionality. So I'm going to go ahead and write this down, and I would like you to write down the notes with me. Direct variation is the same as proportionality. So the definition for direct variation: when two variables have a constant ratio of x to y. Now we can write this in our own words here. So we can actually say this definition, what does this mean? This means that how much you multiply the x by to get y. So I'm going to go ahead and write that down. In other words, how much you multiply the x unit by. I say unit because we're always talking about units when we're talking about rate of change or proportionality, or we're looking in a graph. So how much you multiply the x unit by to get the y unit. What I'm going to do is I'm going to use this little table right here as an example. So we have a table of hours to miles. If we think about the hours as our x and the miles as our y, what we need to do here is to figure out how much we multiply x by to get y. Well, right here, if we have 1 hour and 60 miles, this is 1 times 60 to get 60 miles. 2 times 60 to get 120 miles. 3 times 60 to get 180 miles. So you can see right here we have two variables, and there's a constant ratio right here, 60. And what we call 60 is our constant of proportionality. Constant of proportionality. And you might be thinking, well, this constant of proportionality that you call it, isn't this just the unit rate? And it is. The constant of proportionality is just a unit rate without the units. This is my shorthand for without the units. So like I said, I'm throwing some new terms at you. We have direct variation and constant of proportionality. But in reality, the concepts themselves, proportionality and the unit rate between them, is stuff that we've already seen. So how can we find the constant of proportionality? Right here, we have a table. And what I told you, direct variation means that the data is proportional. How do we find out if data is proportional? We check and make sure that all the unit rates are the same. So if we look right here, we have $12 to 1 hour. Our unit rate is $12 per hour, or 12. And we're going to check this here. Now we have $24 to 2 hours. Again, we get 12. We can go ahead and check all of these data pairs. 36 to 3 is 12. $48 for 4 hours is going to give us 12. So right here, we can say our constant of proportionality, and we like to use the variable k for constant of proportionality. So I'm going to write k equals 12. This is no different than figuring out if this table is proportional. To figure that out, we would find all the unit rates. If the unit rates matched, then we would say it was proportional. And now we can say that it also is direct variation with a constant of proportionality of 12. Now I'm going to show you how to find the constant of proportionality looking at a graph. This graph right here forms a straight line, so we know that the rate of change is constant. We can use this graph to find the constant of proportionality. Just remember, to find direct variation, we need to figure out how much we multiply the x by to get y. So if you think about that, our k, a constant of proportionality, how much we multiply x by to give us y. Just like solving an equation, if we wanted to solve for our constant of proportionality, we would to find k, we're going to divide both sides of this equation by x. That's going to give us k is equal to y divided by x. Now that we have this formula here, we can use any of these points to figure out what our constant of proportionality is. Looking at our first point right here, 5, 2, we know with an ordered pair, it's always x comma y. So in this case, our y value is 2, and our x value is 5. That tells us that our constant of proportionality is 2 over 5, or 0.4. Now, we did pick this first point here, but we could have picked any point on this graph because we see that there's a constant rate of change. For example, if I were to pick the next one, 10 comma 4, again, we know our ordered pair is x comma y. If I wanted to find my k, I would know k is equal to y divided by x. Our y in this case is 4. Our x value is 10. So again, we get 4/10 or 0.4. So that's how you find the constant of proportionality using a graph where there's a constant rate of change. Last but not least, we could also say, how do you find the constant of proportionality given an equation? Well, like we just said in our last slide there, we know that y is equal to kx. It's the constant of proportionality times x will give you y. It's how much you multiply x by to get y. So in this case right here, it's very straightforward. Our k value is going to be 10. Our constant proportionality in this equation right here is 10. Now what I would like you to do is go to your textbook, page 83, and I want you to try both letter B and C.